So I'm here at University College London with Professor of Astrophysics Giovanna Tinetti, who is also the principal investigator for a new European Space Agency exoplanet mission that's due to launch in 2029, the ARIEL mission. And Giovanna is heading up is a PI of a consortium of universities, 50 universities and institutions who are participating in the mission. It does have some participation from NASA and JAXA, the Japanese Space Agency. And tell us, Giovanna, exactly if you had the science drivers for this mission and what you hope to get from this 2029 ARIEL mission.
ARIEL will be the first mission that will provide a chemical survey of the planets in our galaxy. We have now discovered more than 5,000 planets orbiting our stars, but we still know very little about them. And so ARIEL will provide for the first time the chemical compositions of hundreds of planets around different types of stars. And by studying these planets, by studying their chemistry, we will understand much more about these worlds.
And you yourself said that you are not necessarily interested in finding an Earth 2.0. That's not your personal priority. Why is that?
I think it's a very interesting question to understand, how many Earths or planets similar to the Earth out there. But I think I'm more interested about the big picture. And so understanding in general how planets are forming, how they're evolving our galaxy, before really addressing the specific questions. So I'm interested not just about the twins of the Earth, but also the cousin of the Earth or the siblings of the Earth. I think all these planets will tell us a different story, and it will be very, very important for us to understand all this variety.
And tell us just a tiny bit about how the observatory, the telescope, it's like it's an elliptical telescope, how it's going to work.
ARIEL is a 1 meter class telescope, and it will be launched in L2 at 1.5 million kilometers away from the Earth. And what ARIEL will do was to do spectroscopic measurements, so meaning we will split the light that is detected out of exoplanet atmospheres into different wavelengths or colors. And we know that molecules are absorbing lights in a different way, in a different pattern, according to wavelengths. And so by looking at the spectra, we will be able to understand what is the chemical makeup of these worlds.
So UCL has a very good reputation internationally for astronomy and planetary science. Tell us a little bit about the history of University College London. You were telling me that on the elevator just now.
Well, I think UCL is a very interesting story because historically it was funded by Jeremy Bentham, and it was a visionary, it was a philosopher, a scientist, and he really considered and thought that university should be open to anybody. And back then, at least in this country, university in Oxford and Cambridge in particular, were only for men, and they were only for Christians. And so UCL was really one of the first university to open to women and also to students of different religion. And so I really like that even today there is still this openness. We're still thinking globally, and we're still welcoming people from anywhere in the world with different backgrounds and different thoughts.
So thank you so much for taking the time to talk to us today. Good luck with future developments with ARIEL, and thank you very much again.